Hi, my name is Kylie Loveday, and today I'll be doing this mini lecture on correlation and causation. Now, one thing that is crucial when we think about correlation is that correlation does not necessarily imply causation. Why is this? Well, it is important to remember that it doesn't matter which variable you call the explanatory predictor variable and which variable you call the response outcome variable. The correlation score will be exactly the same. A second reason is that correlation measures association only. The association can go in either direction. Both variables could be affected by a third variable, or a correlation might be spurious. So, say we have a correlation between two variables. Let's use our example of stress and hazardous drinking. We found a moderate strength positive correlation. How are stress and hazardous drinking related? The first possibility is that there is indeed a causal link in one direction. Higher stress causes students to drink at a more hazardous level. Increases in X are driving increases in Y. But maybe it's not that simple. There could be a causal link in either direction. Does an increase in stress cause a person to drink at a more hazardous level? Or does drinking at a more hazardous level cause a person to feel more stress? A correlation analysis cannot distinguish between these two possibilities, and this is a limitation of the correlation approach. Ideally, you would want to manipulate one of the variables. For example, make one group quite stressed and see how that affects the other variable. For example, do the stress group then drink more? But of course, it wouldn't be ethical to do that, so correlation is our only option to get at this question. Now, a third possibility is that increases in X and Y are actually driven by a third variable. If you plot shoe size and reading ability in children, they are highly correlated. But in fact, both can be explained by a third variable, the child's age. The older a child is, the larger their feet are likely to be, and the higher their reading ability is likely to be. The final possibility is that there is in fact no obvious causal link, and we call these spurious correlations, when two variables are correlated but have no direct causal effect. For example, let's look at the number of active Facebook users across time between 2005 and 2011. What you can see here is that there is a dramatic increase across those 6 years. But let's also plot the yield on 10-year Greek government bonds, essentially a marker of debt. And these two variables quite closely align. But clearly, Mark Zuckerberg is not using Facebook as a way to bring down the Greek economy. Much as the decreasing number of pirates, here the x-axis is reversed, is unlikely to have caused an increase in the global average temperature. So these spurious correlations are usually just due to coincidence, with the possibility that there may be a third unmeasured variable. For example, road rage incidents are correlated with ice cream consumption, where temperature is the factor that is thought to be related to both of these factors. You can visit tylervigan.com to see some interesting examples of other spurious correlations. The difficulty can be that people might find it hard to accept when things occur by coincidence. When chance events lead to important consequences, it is hard not to come up with a complicated explanation for it. We prefer to think of things as being causal, whereas this is often not the case.